completion of this chapter, the student should be able to understand the importance of keeping a visual lookout, recognize the dangers of relying on operational alarms to warn of the presence of other vessels or impending close-quarters situations, explain why small predicted passing distances must not be relied upon, state how sensor input alarms only operate on failure of input and do not respond to inaccurate inputs, recognize the dangers involved in using automatic acquisition of targets, and understand the possibility of bearing errors. The use of an ARPA radar is no substitute for keeping a good visual lookout. Remember that an ARPA radar is not a foolproof system. Smaller targets may remain undetected by the radar. The system may have errors in it, leading to unreliable information. It is also important to always check the quality and reliability of the information obtained by the ARPA radar. You should never rely on operational alarms only to warn of the presence of other ships or of a forthcoming close-quarters situation. As you already know, the automatic acquisition methods available on most ARPA systems have their limitations. For instance, an echo that first appears inside a guard zone ring will remain undetected. The ARPA is an excellent anti-collision system that can provide the navigator with useful information in very short time. The CPA, TCPA, and bow crossing ranges of targets are used by the navigator when assessing a traffic situation. Some navigators believe that the information obtained from the ARPA radar is so accurate and reliable that it allows them to reduce passing distances from land or other ships to a bare minimum. That is a very dangerous and irresponsible attitude. Always give yourself a safety margin and never accept short predicted passing distances. Here are some important factors worth remembering. The passing distance of a target varies with the target size, speed, and aspect. There is a delay in the detection of a target's action. Occasionally, lost target may occur. The ARPA radar may have errors in its sensors, hardware, or software. Minimizing the passing distance from traffic may lead to confusion on the part of other ships as to your intentions and the unnecessary development of a close-quarters situation, which is undoubtedly in breach of the COLREGs. An ARPA radar will give an alarm in the case of sensor input failure. It will, however, not give any alarm responding to inaccurate input. Inaccurate sensor input will result in inaccurate calculations, especially with regards to the true motion and true vector mode, and when using the trial maneuver feature. The accuracy of sensor input must be checked at regular intervals. It is, however, worth remembering that incorrect speed or heading input will not influence the CPA or TCPA. They will always be correct. These are based on the relative bearings and ranges of the targets, and if these are correct, the CPA and TCPA are also correct. Think about the relative plotting triangle. The CPA and TCPA is found before own ship's speed and course are entered into the triangle. Most modern ARPA radars provide a feature for automatic acquisition of targets. This feature may reduce the operator's workload during busy periods, thus contributing to safer sailing. However, the operator should be aware of the fact that most ARPA systems are less sensitive in auto-acquisition mode and may miss out on smaller targets. An ARPA in auto-acquisition mode is also unable to distinguish between important and less important echoes, but may acquire any echo within the zone. A responsible navigator will never rely on the automatic new target warning only, but at regular intervals visually observe the ARPA display to make sure that all important targets are acquired. It is important for the performance of both the radar display and the automatic tracking that the bearing error is as small as possible, preferably better than 0.5 degrees. The radar antenna was aligned during installation, but you should check this alignment regularly. The antenna bearing alignment can best be checked when the vessel is heading straight towards a small object that is clearly visible both visually and on the radar screen. The object should then be exactly in the middle of the heading line on the radar display. If not, an adjustment is needed. Own ship's roll and pitch motion will introduce an error in the bearing measurements to a target echo. The size of this error depends upon the roll and pitch amplitude. A 10-degree roll will result in a maximum offset error of 0.22 degrees. A 15-degree roll, as shown in our example, will result in an offset error of 0.5 degrees. As you can see from the graphical presentation, the bearing error will peak in each of the 4 quadrants around own ship for targets on relative bearings of 045 degrees, 135 degrees, 225 degrees, and 315 degrees, and will be 0 at relative bearings of 0 degrees, 90 degrees, 180 degrees, and 270 degrees.